Welcome back to Think Design Work Smart. I'm Nils Wloka and I'm coming to you from the Mosaic Work Studios, and today with a guest we'll do something a bit different. We will explore a topic that we don't fully understand, either of us, and we'll try to come up with some ideas on it. But before we move on, let me introduce my guest. Hi, Nils.
Hi, Alex. Thanks for having me.
Can you first introduce yourself a little bit so that the people watching this will know why we are discussing about these things?
Yeah, I can do that. So I probably start at the end, and then it's going to be easy, and then I can still choose how far to go back. So I'm currently VP of Engineering at steadybit. We are a chaos engineering platform vendor, so basically provide a tool that other folks can use to conduct chaos engineering experiments. That's probably one of those topics we don't still fully understand that we will be discussing today. Not only responsible for the engineering team, but also for all manners of product management within the team. And that's, I guess, how we started this very conversation, because when I was doing research in that role, I was stumbling about a few things that are still puzzling me, right? And I posted that on Mastodon, and that is where Alex picked me up. I've been in software engineering, I guess, for all of my life in all kind of different roles. Started as individual contributor, so software development, but quickly discovered that I prefer working with the people side of things. I think this is also how Alex and I first met. That was like 10 years ago at Agile and Lean Network conference in Bucharest. Yeah, so did that quite a while. Later pivoted into product management. Started to invent my own services back in my days at Codecentric. Yeah, and finally pivoted again into engineering management, and this is where I'm currently am.
All right. So let me start by introducing the post that you are discussing about. It's on screen. You cannot see it, but the audience will be able to see it.
Awesome. Yeah.
So this was on 6th November 2022, at least the first one that I can find. I still don't understand how Mastodon works, so some of the posts have been lost, I think. And what you are saying is that chaos engineering is not something you can easily tie to some other deliverable. It's explorative. You can say what you'll find up front. It's probe, sense, respond in complex environments, after all. When you find something, it will create more work down the road. It's more like an insurance against the unknown unknowns. So communicating your hypothesis in terms of business risk is what you are referring to. Now, if you could go back a bit and explain a little of the context, as much as you can, because maybe not everything.
Yeah, I can definitely do that. Yeah. So, I mean, first of all, when I'm talking about chaos engineering, I think I'm no longer an actual engineer, right? So I hardly code these days. I haven't grown up with all these complex pieces of infrastructure that abound these days. So I probably approach it from a different angle. And for most people, chaos engineering is probably exploring their architecture and figuring out where to introduce a circuit breaker or retry or these kind of things. For me, when I first joined steadybit, for me the obvious analogy was always, hey, this is probe, sense, respond, right? And this is something I'm super familiar with because I'm coming from an Agile background, as we just found out, and in the job before this one, I was mostly doing Kanban and Lean, and it felt super similar just on a technical level, right? So introduce some kind of stressor and then observe. But whereas it felt, well, I think okayish to do that with processes, we did research and we found that a lot of teams know that they are surrounded by complexity, but then still never draw the conclusion that that sense making is something that they need to engage with, right? So it'll pile up, complexity will pile up, and at some point there's catastrophic failure, and that is usually the first point at which we tend to move. And that is basically the puzzle in my head that made me post this thing, right? It felt like everyone knows that we somehow have gotten us into some form of mess because systems have become so complex. And we, from other domains, and maybe with chaos engineering, even in the engineering domain, we have some of the tools at our disposal, yet it seems incredibly difficult to actually start doing it for various reasons.
Okay, so let me try to rephrase this, and you will tell me whether I got this approximately right or not. I see two aspects of chaos engineering. One of it is the techniques. It's and the mindset. The mindset of saying things will break anyway, so let's try to break them and see what will go wrong, and then fix those things. And this is one. But the other thing is the incentive. When do you start doing this? And to me, it feels like you are talking more about how do we get to the incentive for doing chaos engineering rather than actually applying the techniques. Am I close, or?
Yes, I guess that's part of it, right? I could probably talk about some of the techniques. I believe it's not just about figuring out when your technology breaks. It's also about figuring out when your organization breaks, right? So you can use that stuff to conduct fire drills and harden the processes around incidents. So I think there's plenty of to explore there as well. But as you said, the thing that puzzles me the most is with things breaking constantly, and it being so difficult to understand why they have broken. Why is there this super high threshold to start being more proactive about it? Right. So what kind of incentive systems? I mean, I've been in that role as well as product manager and as engineering manager. What are the kind of systems that we have created that seem to make proactivity not the most valuable mindset, right? So that's the stuff that's puzzling me, and I would love to explore that together with you, because I believe as a consultant you will probably also see these kind of situations in different forms at your clients, right?
Yeah, absolutely. I mean, I believe it's a matter of journey in a way. Because what is the initial mindset of developers? Let's make things work, right? And this is what you try to do. You try to make things work, and from the first moments you start writing code, that's the main thing that you do. So this is what you have the most practice at as a software developer. And I know we have engineers and so on, but honestly, what we are doing is software development most of the time. It's less engineering. And once you get over this thing, you get to the next step where you are working in a team, and suddenly other people need to understand what you've done. And then you get hit with the second thing, with not only things have to work, but also other people have to understand it. And then you deploy that thing, and maybe you have another team monitoring and doing all this stuff, and you get the incidents back, and then you figure out, oh, now I need to fix incidents, because otherwise, people will wake me up in the middle of the morning to fix stuff. So, and I guess that the problem is, for some organizations, they haven't gotten to, either the feedback is missing, so people who would be able to prevent or to have this mindset of prevention are not the ones that are called in to fix the issues. You have other people fixing. It's like what we had in the past. When I started programming, I would write code, and then somebody else would test it 6 months later, because that's how we used to work. And then afterwards, if I was lucky, another programmer would get the bug to fix.
Yeah, so that's the project mode, right?
Yeah, and the issue with this is that I had absolutely no feedback on my work. Right? I didn't know that I introduced a bug because somebody else would get it. And I think my feeling is that what we are seeing with preventive things related to complex systems is on the same level, but kind of the same problem, but on a different level, actually.
Yeah, I can absolutely confirm that from part of the research that we did. So one of these, or let's say a cluster of habits that we've identified that keeps people from starting any kind of preventive measures. We weren't even specific about chaos engineering in that research because it's really just about how do you become more proactive when it comes to quality, stability of your system. So one of the habits that we have been seeing is the one that you just mentioned, right? Because it doesn't hurt me either yet or at all, right? So it's something that that just doesn't feel like part of my job, and I don't even maintain that this is a mindset thing, right? It's sometimes the organization is structured in such a way that it actually isn't your job, and that you would have to fight for making it your job, right? And that by the way is the thing that reminds me about back in the days when we were trying to push for test-driven development, test automation, right? Same thing. It felt like something that we don't necessarily need to do as part of our role. So if we wanted to do it, it would be in conflict with all the things that folks considered being part of our role, namely building new stuff, as you said, right? And getting it into production. And this is the weird thing, right? It feels like same old story repeating. So teams seem still to be managed in a way or incentivized in a way that makes them prefer building new stuff, even while they are aware of the fact that they are slowly losing control. Right. And it's not a mindset thing, right? We've talked with tons of people who knew that, who almost felt ashamed for behaving in that way and still felt like this was what was expected of them. Right.
Yeah, and I think there are more factors in play here. One of them is psychological. So I found it very interesting that psychologically, if you look at how basically the brain structures information and knowledge, future you is a different person than today you.
Yeah.
So, and this applies to a lot of different things, like to exercise and to health and personal good habits and so on, that you know will help future you, but are difficult to do today. Right.
I mean it's a bit similar to that saying there's no glory in prevention, right? Right now you get more gratification, better feedback, more feeling of progress when you just build the thing, instead of what I wrote in that toot. I guess toot is the word, right? On Mastodon. In that toot of mine, it's like, okay, you do chaos engineering or any other kind of sense-making activity, and the best thing you end up is you'll have plenty of work to do now that you didn't have to do before, right? So yeah, I get it. Yeah. On the other hand side, folks are feeling inherently uncomfortable. So it seems to be that part of future me is still already nagging, a nagging voice in my brain that's telling me, oh man, it's when you become future you, it is going to be super painful.
Right, but there's always the hope, and I mean this, it's always the hope that it won't get to you. Maybe you left the organization. I think it's only a matter of timeline. It's like I've seen a similar problem with architecture. So people who get to do architecture are usually good developers who turn into architects, right? But making good architecture is a completely different thing than writing good software. It's a very different mindset and different practices and so on. And one challenge with architecture is that it takes a long time to see the results of your decisions. It can take months, it can take years sometimes. And so if you are not there for a long product and to see the results of your decisions, you might end up with the idea that you made good decisions and basically reuse the same decisions for other architectures later on. And I think the same problem is here, because if you are in the beginning of a product, chaos engineering and these things will only hit you later on when it becomes really complex.
Yeah.
And this might take years of development.
Yeah, I think you said two things that resonate super well with me and with some of the observations that we made, right? So there's, first of all, these kind of activities, and I guess especially chaos engineering has a sweet spot, right? You don't need to do it if you already know that everything's broken, right? It doesn't make sense. So you need to achieve a certain point of or a certain level of stability, and then it's exactly in that moment that you can also convince yourself that future me is never going to happen, right? So it's pretty difficult timing wise, which also means that the strongest trigger that we've seen before folks start adopting chaos engineering is when future me is actually knocking at your door, right? So it's always the catastrophic failure that you will remember forever, and that will change how you perceive these things. So that is true. And I guess it's also, what you said about feedback loops, right? I mean, this is a preventive measure. So if you do it right, nothing will happen. And it's pretty difficult to get positive feedback out of something not happening, right? So that might be one of the strongest psychological effects that can keep a team from doing it. It's like, okay, we did it. We can't prove that it did anything good for us because things simply didn't happen. So that's one of the things that we are constantly striving for from a product perspective, right? Make it as easy as possible to get some form of initial gratification, guide folks to that first experiment that will open their eyes and make them see that, okay, if we hadn't done that experiment, next week might have been the big one, right? So I guess that's, correlates a lot with what I'm seeing.
Yeah, and then it's also a matter of mindset, which I can definitely understand. I mean, I always get the feeling that developers tend to be overly optimistic, right? And I think because we focus a lot on let's make things work, and already this, well, if you're not using practices like TDD and these ones that help you build on solid ground, then it's already very hard to make things work. So you need to keep on being optimistic while you are doing that. And I think this is why it's very difficult for developers to adapt to the negative mindset of security. That's another one, right? What could break our system? What could somebody do to get into our system and do bad things there? And the second one is when systems fail because they fail. It's
so personally, I don't really buy into that whole concept of mindset, right? This implies that someone gets to choose what mindset to have, right? It's like, hey, there's some stereotype that developers or engineering types conform to. I have a feeling that the answer must be somewhere in the systems that we are creating. And we, in my current role, means, so what's the kind of expectation that I'm communicating to the teams? What is product management doing? What is the stuff that folks feel gratification for, right? And I guess that's naturally going to form a specific mindset. I mean, all these teams and all these individuals that we talk to didn't think it's not their job or shouldn't be their job. It's really like, okay, this is the list of stuff that I need to do. This is the list of expectations that I need to fulfill. And there's I can only choose so many things to put take on top of this. And then these preventive measures, especially with all these psychological effects that we just discussed, make it super unlikely that chaos engineering or some other of these activities will actually make it into a given sprint or into a given roadmap. And I have a feeling, and this is something I think I also put down in the Miro board that we used when preparing for this. Maybe it boils down to the fact that there is still this misconception between what's a functional requirement, what's a non-functional or a quality requirement. Maybe that's one of these holes that we dug ourselves into right now. It's okay. Product management will talk to you about functional requirements and about the nice next feature that needs to be built for that customer. And engineers automatically need to make sure that also all these implicit non-functional requirements are to be respected, but ideally without investing time. And if there is a trade-off, then please instead build the feature. And this holds true until the big one, when the first escalation call happened, right? So it feels like it's more like we are fostering a certain mindset, and I'd love to understand how we can get out of this.
Right. So I think you are right about the mindset that is a lot formed by the culture of the organization. Sorry. And what I was talking about is more like the baseline mindset, where you start as a junior programmer, let's say, freshly hired and so on. But then everything else needs to come from the organization. And I'm actually showing now the Miro board because I think it's quite interesting what we have here. And you mentioned this, that liability does not seem to be perceived as a feature. It's a non-functional requirement versus functional requirement. And that's a very interesting point because I think one of the challenges with it, maybe it's not a very good classification, but some of these things that we call non-functional requirement are more like systemic. How do you call them? Systemic requirements from, or systemic expectations. Because they are things that apply to more than one component in your system. Yes. More than one class, more than one service, more than one. It applies to the whole system. And it's also a very different approach once you get into that world. I mean, we can see this on one hand with managers who move from managing projects and let's say the traditional style of management into managing in the complex domain in agile organizations and such. And I think it's the same jump from focusing on your own piece of code that you are changing today, be it a service, a component, a library, whatever it is, to managing, to thinking about the whole system, how it works.
I mean, that makes a lot of sense for me as well, right? Because at that point, sense of ownership probably starts dissolving. It's like, hey, I mean, the one thing is tangible. It's the stuff that I have open in my IDE every day. I can pinpoint it to some website or some application that I can actually look at, and I know this is the part that I own, that I'm responsible for. And then there's this abstract thing cross-cutting through all of it that I couldn't even own if I wanted to, because it's, I mean, that's the first card there, right? It's an emergent property. It's not something I can immediately influence. I'll be a part of it, but in the end, it emerges when all these things are put together. And that would also explain why the organizations that we see adopting chaos engineering usually do so in a centralized way. There is some unit in these organizations that owns that particular abstract thing and starts making it tangible by having OKR, KPI, counting number of performance-related defects or whatever. And at that moment, it really takes off because that whole invisible thing suddenly becomes something that they have in their IDE every day, and they start working on it much like engineering teams work on their features. So, I mean, that the question is that actually viable in the long run, right? Is that sustainable? There's a lot of talk about left shifting these kind of efforts, especially when you are taking into account DevOps, your build it, your run it. The question is whether this can even happen, whether left shift can be successful, given that you can't own the whole thing in one single place. That's what makes me wonder.
Yeah, and I have to wonder about the technical solutions as well, because how do you figure out that you need to fix something on a systemic level? You figure out, you can look at one component and say, okay, this is talking to the other components, what happens if those fail? And that's a simple thing, that you can do this locally. But what about things like cascading failures?
Yeah.
Right? When something fails and brings down other things and then maybe restarts, but then provokes other failures and so on. These are things that are very difficult to look at locally. And if teams are focused on local stuff, it's almost impossible to look at the system as a whole.
Yeah. Yeah, that's an interesting point, and I mean, switching into the engineering nerd perspective for a second, also a pretty hard one to tackle when it comes to building a product that can help with chaos engineering. It's basically, how can I still provoke the effect while maintaining a certain control over the blast radius? Because I mean, it needs to be. It needs to be allowed to spread out, otherwise you can't really explore the real possibility. But ideally you can still do it so that not everyone's component is affected, so that then results in trying to figure out, hey, can I make a certain service seem unavailable just for another service, right? So that's some of the real challenges that are coming back from teams that are working with our product. So seems to correlate, right, with the observation that you somehow need to go beyond your local scope.
Right, and the way I always thought about this is that you start by defining your target for reliability. So you start by saying, okay, so I need 6 nines or 5 nines or 3 nines or however much you need. And that gives you a translation into how long you have to fix broken stuff per day, per week, per year, and so on. And this is already a very good indicator. I like to show in the architecture courses the list of from 3 nines to I think to 13 nines or something like this. And it starts very easily, like you have a few hours to fix things, if you are on 2 nines or something like that. But then if you go to 13 nines, you have a few milliseconds per year to do that. So then it's a completely different mindset. Now, I think the challenging thing is to translate this from business requirements, because if you ask business people, they will tell you it has to be always up. But we know
no nines, just 1 1 and 2 zeros.
110%. And we know it's not possible as engineers. So then we need to figure out where we are in this.
So, I mean, what you are talking about is basically error budgets, right?
Yeah.
So, I mean, And I think they are a incentive pointing in the right direction. I think my personal problem with them is, again, they are mostly reactive, right? I mean, you take your service level agreement, you turn it in a service level objective that is a bit more conservative, so you create some implicit buffer. But then again, you will only start once it's becoming a problem. I mean, maybe it is what it is, and that's the best way we can actually achieve. I kind of feel, though, that we've gotten around this when we introduced all these nice agile software development, the stuff that's nowadays called software crafting, right? Test-driven development, pair programming, peer reviews, whatever you do these days. So at some point we managed to switch from doing it after it didn't work out to just accepting that you could somehow integrate it into your routine, and then you will save yourself a lot of work after the fact. And that's, I wonder whether this is also achievable with these systemic topics, right? Maybe the problem is still too young. Maybe the tools are not mature enough. But I have a feeling that in the end, it's a lot more pleasurable to figure out how to make parts of your system more robust in the laboratory than struggling to maintain those to stay within these 10 hours that you have to get it back up and running before you start to pay money, right?
All right. So then I wasn't precisely meaning error budgets. What I was thinking about is if you start your architecture from this constraint, basically.
Yeah. Okay. Yeah.
Then what you need to do is to look at the whole architecture and the components separately to figure out whether they fit, and also at vendors, because sometimes you'll get external services, whatever, and then you need to make sure that they fit your need for reliability. And this might involve some guidelines, like we'll use circuit breakers everywhere, or we'll use circuit breakers for specific things. It might involve deployment changes, like we'll have 2 instances of that thing and switch from one to the other in case they fail. We might look at what we show in the user interface, do some kind of, how is it called? I always forget it. Graceful degradation.
Yeah.
And so on. So this is actually a systemic effort. But my feeling is that unless you've actually done it before, it's very hard to make this analysis. And I'm not sure. I mean, this is where tools would actually help.
I mean, this is my first reaction when you were explaining this was like, wow, once you've done that would be the perfect moment to actually try it out in reality, right? I mean, probably too early from a development point of view. Would be nice to do chaos engineering on an architecture concept, right? Like ATAM or something, architecture trade-off analysis method, where you actually do do as a thought experiment, do thought experiments with certain stimuli that can interact with your architecture, right? But at some point you will reify your architecture, maybe when you are doing your first vertical spike. So it kind of feels like, especially if you're venturing into the unknown, and I mean a lot of teams who are converting to a DevOps cloud native way of delivering their application are suddenly confronted with a kind of territory that they haven't been in before. It feels like this would be the moment where you would do these kind of things, much like when I'm solving a certain business when I'm writing domain code for a new business problem for the first time. I still feel the need to write the test first, right? So that I understand that I understand my own understanding of the problem. And this is something that I don't really see happen that often. So we are talking so much about the things that we don't see. Do you have, from your personal experience, do you have examples of where it's working differently? Do you have have you seen organizations that are more proactive than others in doing this kind of stuff?
I mean, more or less. There's a recent example in that's quite funny in a way. ING Bank in Romania, they did a reliability test at some point, testing out what would happen to their data center if there was a fire. And what was very ironic is that the whole system went down for like 6 or 8 hours, something like that. It was on a Sunday, so it wasn't that bad. And I always give this as an example, because from the perspective of customers, if it was not great, of course, but from the perspective of a reliability test, it was perfect because you found the problem.
Yeah.
And this to me is, I think, one of the big challenges, because you have to think in a completely different way. Right.
Yeah. So have you been working with them?
No, not directly, but there was a whole case study, and I read the post-mortem, and and I heard also from other people in the industry.
Because what I'd love to understand is what makes people change their mind on these things, right? So when you said when you were mentioning a financial institute, I still remember a conversation that I had with a prospect from the financial industry, and I dropped that very sentence. So yeah, there's no glory in prevention, and they were like, there is a lot of glory in prevention in our place. So what makes organizations start perceiving glory in prevention? Do you have any examples?
Well, I think I have been working in the past years with banks and financial institutions, and one of their main incentives is to keep up the service, particularly payments. And payments are the most important part, right? Because credits, okay, you can get credits next day, it's not that big of a deal. But payments are very important. So whenever I worked in this area, and I happened to work in this area a number of times in different organizations, I noticed how careful these people were with their infrastructure. So I think it's because it's very clear that it's a core business. It's something that actively hurts the business if it goes down, and it's a responsibility that they take and that they enjoy oftentimes to keep this up.
So is it more tangible, right? Because I guess, almost everyone working in software by now will be responsible for some critical part of either a supply chain or a customer service. So does the financial industry manage to project that feeling of you being part of this whole thing better? Is it that folks who seek that kind of thrill are joining the financial industry? Do you have any idea? It would be lovely to figure out how to create an environment in which everyone feels as connected to the actual service they are providing as these folks, right?
I'm not sure, but I think there is some kind of self-selection there. Because if you look at payments from outside as a programmer, they look quite boring, honestly. It's not something that you would say, oh, it's changing the world or whatever. But there is a certain type of people, and I'm thinking here also about, people who maintain systems or more operations oriented or minded, who are very attracted by this kind of thing, and I can definitely understand it. So I'm also one of them. So when I look at things like payments, when I look at things like making systems that actually work and stand up for long periods of time and stand the test of time, this is something that I find very, very cool. But I also realize that part of it is a lot of boring work if you don't have this incentive, right? Because what you need to do is to continuously think about what could go wrong. Let's make just small steps, just figure things out and don't break anything.
So that is an interesting one, right? It's maybe it's a bit off topic, but what you just said reminds me of a keynote of Andrea Goulet for XP conference in Cologne. So she was talking about two different archetypes of software engineering people: makers and menders, right? Folks who enjoy building new stuff, and then folks who enjoy taking all that shiny new stuff and make sure that it'll survive forever. So maybe that's the key, right? Finding the menders and help them do these things. And now that I'm saying it, it's actually one of the patterns I've also seen in my research. There's the odd individual who goes above and beyond what everyone else thinks is reasonable, writes most of the tests, makes sure that these little details are fixed because they don't want any broken windows. So yeah, maybe that's part of it. And maybe then there's a certain industry who attracts more menders than other industries.
And also think about TDD, because you talked about TDD for a while, and it's how many tests do you write? So you could write only the number of tests, and I've seen this pattern. There are people who write only the number of tests that show that the functionality is in there, and they stop there. I always get the second step where I write the more paranoid tests.
Yeah, let's see whether I can break it. Yeah,
exactly. Things that I know would probably pass, like, all kind of characters available in UTF that should work, right? Because it's UTF and we know the language supports, but still I write those tests and I type all the accented characters and the weird ones just to see whether these things work. So I think it's also this type of thinking that you can see with TDD practitioners as well.
So then on an organizational level, it would make sense when we are talking chaos engineering, site reliability engineering, whatever. So then it probably would make sense that the more there is at risk, or the more risk you feel, the more likely you are to actually engage in these activities. And that might actually reflect in the kind of conversations we are having, right? So it's usually the verticals like financial industry. Interesting enough, insurances, right? Probably because they are selling insurances to other people. It's making them more likely to insure against certain kinds of risks internally. E-commerce, where people can just walk away if you really mess up that, right? So yeah, might really be the level of pain and the way you perceive that pain and how tangible it is that makes you more easily adopt these kind of preventive software engineering methods than yeah.
And I think it's the same with security. So I had one when I was developing a product with a team. At some point I realized, I was looking at the code, and I realized that we weren't validating the format of an image that somebody was uploading. And I was like, guys, do you know that you can actually inject stuff through an image that would get run on a, depending on the library that you use and the operating system and so on. And everybody was looking like me like, what are you talking about? Is this even possible? Yeah, it's possible. Of course it's possible. We need to validate that if it says JPEG, is actually a valid JPEG and not something else, because you never, only the extension doesn't tell you a lot about these things. So I think it's a matter of mindset. And one way I think about this is maybe we should start looking and start teaching developers to look at their code from different lenses. So the first lens is, does it work? And can you prove it works? The second lens is, can anybody else understand it? Or will I understand it in a few months? The third lens would be, can we easily change it in 6 months when a weird request will come in? And the next one would be, can anybody break it? Can anybody do bad stuff to it? And that would be the security lens. And then you go to higher, you can also go to the local lens of how could this break down and stop working? And that would be local reliability.
Yeah. It feels a bit like, I mean, I was spinning these thoughts in my head, right? And at some point, I guess for some of these things, like, I mean, in the beginning, it was just weird folks who were doing test-driven developments, almost like a sect, right? These agile people wasting their time on that stuff, and eventually it dawned on people that we all have a problem that test automation can prevent, and that the problem became so prominent that automating some of my tests doesn't even necessarily need to be TDD, right? So automating my tests and doing certain things that by now are good practice is the less painful way universally, right? So there's some things you universally accept as a good thing, continuous integration, and these kind of things. So maybe it's really that the problem that we are seeing with these super complex systems is still mostly felt by a small group of people who might be more sensitive, might be more exposed to the risk, right? Have seen more complex systems in their time, are the architecture type of people or the menders, and these are starting to adopt these new complex methods. And eventually, when the problem becomes omnipresent enough, it will just diffuse into normal software development routines, right? So it might just be a matter of waiting it out. Not sure.
Yeah, I think one difference compared to other practices that you are mentioning is that this one also needs to be systemic. And that's a bigger jump than just looking at your own thing and making it work.
True.
And I'm a big fan of prototyping. I think we are not doing enough prototyping in this industry because, as you mentioned before, prototypes starting from an architecture and even to validate architecture decisions. This is basically engineering. If you look at how engineers used to build things before we knew how the physics of a bridge works, right? What did we used to do? We built a bunch of bridges until we figured out which one will stand. And then at some point we realized what are the laws of physics so that we can compute them. And that's the same thing with software. You just need to keep prototyping things and make sure that your decisions are going in the right direction. And I think once we start doing this, and with some good enough tools that can simulate some kind of failure scenarios on different components, then we might figure out how to do this in a preventive way. I mean, you see this with Netflix, Chaos Monkey, Chaos Gorilla, and all that, but they are doing it after the fact, not before the fact.
Yeah, and I think, I mean, Netflix is where it all started, so you can't ignore it, obviously. I think there it almost felt like didactic measures, right? It's like, okay, they keep pushing that software that will break, and then we are the ones who need to fix it. So let's just introduce that chaos by default. But looping back what you just said, right? And I mean, connecting it to something that I said earlier, with it's maybe a matter of timing. So there's a good time to do it and a bad time. So maybe it's also a matter of circumstances. If you are safely entrenched in the thing that you've been doing forever, there's probably just not enough risk to warrant picking this up. So and this again correlates with, so one of the stimuli that I just mentioned that causes folks to pick up chaos engineering is it crashed big time. So someone got hurt and someone's now standing on my door and wanting me to change stuff. The other one is I'm venturing in the unknown. So it's those big architecture reworks, migrating from your monolith to microservices, going cloud native, going serverless. So leaving that familiar home of yours that you've been inhabiting with your software development for the last 10 years and doing something where you don't have an intuition of how things will behave. Right? So maybe that's actually a good perspective to look at it from.
Yeah, that makes sense. And I think it's also a matter of perceiving risks. I think we often in this industry, we don't perceive enough of the risk. And one good example has been the switch to microservices that has swept the industry,
Yes.
right? When people who are used to build monolithic applications, they suddenly got into the distributed stuff. And then I actually got customers coming to courses on various kinds of architecture. And one thing we talk about is the CAP theorem, and they were telling me, "Oh, we actually fought against this for a few months, and now you are
It's hard
telling
to
us
fight against theorems.
exactly, and now you are telling us that actually we cannot win this fight because it's a theorem." So,
Yeah.
is this kind of I don't know. It's a certain type of naivete that exists in this industry, and it's charming on one hand because we keep trying things, but on the other hand, it's not always productive, right? And
Yeah, I
I'm
mean,
not sure how
this
to
is
deal with
we
it.
could probably talk an hour and going way off topic. But I mean, might also be related to the fact that as an industry, we aren't super great at building a tradition, right? It's like, so as you said, so folks started to understand how bridges were built, what kind of patterns made sense, and their initial reaction wasn't like, okay, now it's got boring, let's build more bridges that crash on our heads, right? I sometimes have a feeling that we keep reinventing the wheel quite often, but I mean, if we want to do that, then it's still puzzling to me that if we really enjoy that thrill and exposing us to that risk over and over again, sometimes for good, sometimes for bad reasons, where we could probably also talk an hour about microservices, why aren't we wearing helmets?
Exactly.
Yeah.
Okay, so let me go back to the Miro board, just to go a little bit through this and try to get to a conclusion, more or less.
Yeah.
So you had on the left side what I see, non-trivial software systems fail in unexpected ways. Yeah. And we mentioned a few ways here, like cascading failures. It's actually one of my favorite here has been slashdot.org, the website, who a few years ago, I think it was before this whole chaos engineering thing.
Yeah, definitely. But it was chaos engineering nevertheless. You talk about being /dotted, right?
What they did was at some point they changed the configuration of one of their network servers, and it was before cloud, so they had their own network and stuff. And they managed to do a denial of service to themselves.
Yeah.
Because there was a packet sent in the network that would produce a number of packets sent it to the whole network, and then everything grew and basically broke down. So it's very easy to break systems. I think this is one of the lessons here. It's incredible.
And the more movable parts they have, the easier it becomes, right? It's not only the stuff that you are doing, it's also the interactions between the stuff. It might be, I mean, we connect to millions of external systems these days. I mean, nobody's probably perceiving their AWS as a real external system, but it's still other people's computer, right? So,
so that's one. Then reproducing, debugging, and fixing is hard. And I guess you meant about reliability, right?
Yes, I mean that's something I've seen over and over again, right? I mean, before you might mitigate the incident, you might get it to green again, might be stable, but doesn't necessarily mean that you know what has caused it, right? You might, and that's basically the next card folded right in. You get good at fixing the symptoms, but I sometimes feel that going back and understanding why the symptoms have occurred is something that we skip.
Yeah, and this is perhaps one of the practices that I see most often is missing. I mean, I encourage developers on every bug to go and do a root cause analysis.
Yeah.
And for reliability issue, it should be obvious that you need to do some kind of root cause analysis. Yeah. And we discussed that it's not perceived as a feature. And here, what still puzzles you, preventive activities don't seem to get any priority unless there has been a catastrophic failure first. And I guess here we discussed that it's both about maybe knowledge and incentives for the teams, but also about the systemic approach, which is a bit different. And even DevOps, you build it, you run it, teams don't seem to feel the pain or translate the team into preventive action.
Oh, it should be the pain, yeah. So that's a typo. Let me fix that live.
It says pain.
Translate the pain to prevent it, yeah. So, yeah.
So, and I think this is something that I've noticed again and again, that developers tend to get very good at how would I say, living in a painful environment.
Oh my goodness, that's what made me become a coach in the first place. Looking at the whole thing from the outside and seeing how people expose themselves to incredible pain and obviously having become or no longer feeling it, right? Yeah.
Yeah.
I mean, that's what I said earlier, right? I feel like maybe we haven't crossed that threshold yet, right? It took quite a while to introduce different ways of managing complexity, to adopting different, maybe more complicated methods of developing software. But it eventually happened because the pain just grew too big, and there were enough people pointing at the pain and starting to tell folks that there is a way out of it, right? You don't need to hurt yourself every time you release. You could do continuous integration instead.
Yeah. So maybe it would be interesting to think about potential fixes. Because
I mean, I think we summarized. We even discovered a few, right? One of the things that we did is say that maybe it's difficult for these systemic activities because you don't have ownership, or ownership is no longer local. So you could potentially think about creating some sort of ownership. Doesn't need to be an expert group. Could be a community of practice, a tribe, whatever you call these things these days, and have some. Yeah, I mean, it's basically Conway's law or team topologies, right? If you want it to be done, you somehow need to reflect it in your organizational structure. So that might be one of the things that could actually be helpful. If you feel like you are sitting on that ticking time bomb, try and figure out whether there's a way of having someone own it, a group of people or an individual, and make it more tangible.
And I think here, normally I would go for architects. I think they are particularly well placed because they can look at system, they can look at, but it's important to know that it's not only them. It has to be also ops or DevOps and it also has to be the teams. It cannot only be those people.
So you probably need some cross-cutting structure, right? Because in the end, it can only be fixed on a team level. And this is probably also why everyone is talking about left shifting it. Ultimately, part of it needs to be left shifted because the architecture can't architect it away. It will still be the teams implementing it away, right? So, yeah.
And I'm thinking about things like local guidelines or local practices. Because maybe there are a few of them. Things like, let's have circuit breakers everywhere. Let's test what happens if this thing stops working and how can we bring it back to life. Can we restore it gracefully in some way? And these are things that you can test locally. One thing I don't know here is whether you have the kind of tools, like it would help to have a kind of TDD, unit testing framework that you could put over there and say, okay, now stop this service, and kind of a preventive chaos monkey thingy.
Not going to do a shameless advertisement here, right, Alex? But at some point, I'm going to invite you, and we'll have a demo of steadybit. Now I said it. Yeah.
Well, we are talking about this, and I have no problem with understanding a bit more what the tool does. I haven't seen the tool, by the way. So.
Yeah. I mean, if we talk potential solutions, so it might be a fix, right? Relating to that card on the lower left-hand corner, non-functional versus functional requirements. Maybe it's also about starting to not consider this a technical activity as such, and so basically dissolve these isolation layers that between engineering and the business, right? And make sure that both parties perceive the risk in a similar way, that maybe product understands that technical risks are not something that's going to bite the engineer, but that technical risks are something that's going to bite the customer in the end. And the other way around, making sure that everyone gets a bit of that tangible feeling of being responsible for the service that's being delivered.
Yeah, I think it's this is a very important part of. Because honestly, if you talk to business people on the C-level and so on, they understand risks. They understand the risk model and all that, because that's what they are doing a lot of time. Like they also understand flows because they manage cash flows and things like that. So it's easy to explain these things, but you have to get to their language and not to the engineering language.
Yeah.
And maybe for a long time, technology was seen as something that's magical and will just work. But by now, I think most executives understand that it doesn't anymore. So.
Yeah. By the way, I think Gartner has done a nice thing there with their technology trends for 2023. I think they were coining the term of digital immune system. So that might actually be helpful, perceiving it as this, and perceiving a digital immune system as something that's not something that engineers should only engineers should be worried about, but that's as something that's crucial for maintaining your business in a day where in days where customers can basically just walk away if you mess up with your most important services, right? Yeah.
Okay. By the way, I also did a video on Gartner's trends, so.
Nice. I will have to look that up.
Okay, and then the next thing is, how do we deal with the systemic part of it? Because the only way I can see is if you actually do simulations. I can't see.
I mean, that's the core principle behind chaos engineering, right? The assumption is you can sit in front of your whiteboard, you can do analysis on your architecture, but it's by now it's so complex that there will always be emergent effects that you can only provoke if you introduce some kind of stressors.
Yeah.
Right. So maybe making folks, and this might actually be disposition, right? And the engineer in me loves discreteness, loves black and white, loves binary, right? So ideally everything is explainable up front, and I can do my analytic thing and figure out what's going to happen. So maybe making sure that folks are confronted with the complexity of it all, right, and perceive the complexity of it all is something we can do better, right? Like as you said, right, we start doing microservices, but we might not understand what kind of complexity it's going to create. So maybe it's really having opening our eyes more to the side effects of some of these decisions that we make. Yeah.
Yeah, and I think one of the core things here is, I'm not sure if it's the right way of writing it, but sensitize the engineers to systems thinking.
Yeah, potentially, yeah.
Because
and I mean, interesting because it's at odds with trying to introduce better abstraction layers, making it easier, right? So I think it's never been so easy to create a system that's so complex, right? I can do a bootstrap. So I bootstrap myself a microservice-based cloud native application in a couple of seconds, and what I've just created underneath is a monster, right?
Yeah. Because my feeling is that you need a different type of thinking in order to do that. And my feeling is that it's not trained enough. Particularly if you haven't been involved with more complex systems, if you're just starting and so on. Yeah, I think so. So what do you think about this?
That's already a nice list. Yeah.
What do you think about this? Is it useful? Or
I think it is useful, right? I mean, it's obviously not a fixed recipe, but I mean, it's something. So if you feel like you should be doing more, maybe you are an engineer who feels like they are sitting on a ticking bomb. Maybe you are a business owner and feel like there must be a way of maybe getting on top of some of these recurring issues. Then this might actually be at least something that you could try out, right? I'm not sure whether you need everything or whether the sum of it's going to help, but it feels like this is a good explanation for some of the observations that we seem to share.
Yeah, and I also, one thing I'm thinking about is that you don't need reliability and this kind of things for everything. You need for more complex systems. This is one thing that needs to be very clear. And for your important assets also. Yeah. Because
I agree.
Maybe you have an internal HR system that if doesn't work, you lose 1 or 2 days. Fine. Not that bad. Yeah. But if you have something that customer facing, you will get fines or you'll lose income, or if it doesn't work, it
reminds me of something I've heard back in my coaching days, right? It's like, don't use complex methods for complicated problems. So if it's still complicated, by all means, just do your engineering thing. If you are building a completely new type of bridge, maybe wear a helmet. Right. So, yeah.
And, but I think it also could help people train a bit more on at least on thoughts. So one thing I am thinking about is, even if you have a very simple application, you could go through some of these things just for the sake of it, just to look at what you could do. And
don't want to derail the conversation too much. So that's the thing that I thought about when you said, hey, this is about testing an architecture for robustness. I guess there's plenty of other ways you can use this for a more systemic resilience engineering approach, right? So I've talked to teams who are using it to test their observability. It's like, okay, we think we know what's happening. So if I push that button, this light should turn red. And then you push the button and the light stays green. It's like, oh, that's bad, because we don't know, so we don't sense deep enough. So that's one of the things. But I've also talked to teams who are using it to actually train their incident response, probably close to what Ing Diba was doing when they simulated that. I mean, it's a literal fire drill, right? So if there are certain things that will break unexpectedly, maybe break them in a way that you can fix easily instead. So maybe just simulate the fire instead of completely burning down your data center, and see whether folks can handle these situations. Because I mean, that's also true for incident responses. I guess you want to train it in as real a circumstance as possible, so that you feel prepared for the rush of adrenaline when the real thing happens.
Yeah, and to me that incident was also a very interesting case study from point of view of communication, because one thing with these types of incidents is that you need to have also communication plan. It needs to be business over the whole business. And you could see people getting back from their holiday houses or stuff like that, because it was on a weekend.
Yeah.
And you could see the news coming from, the PR representative, but who was obviously someplace else.
Yeah.
But they had a good message, which came a little bit late and so on. But it was quite interesting to see the whole thing.
Should we do should we get the opportunity to do a sequel? That's maybe one of the topics we could explore, right? So it feels like, so this just struck a chord with me. It's like maybe it also requires a certain culture to do it, because you are obviously trying to find out flaws, right? And if having flaws is something that's not, or if detecting flaws is something that's perceived as not beneficial, right? So it's a means of blaming folks, then this is not a natural activity to do, right? It's rather, hey, get good at fixing it. Just regard it as a force of nature, and then it doesn't become something that someone might blame you for.
Exactly, and that's one thing about systems thinking, and because you always look at the system. I keep being reminded by the GitLab issue, and when they actually deleted the client database and the backup, if I remember correctly.
Yeah, I think, yeah.
And the reason was that a junior developer was able to run a script, and by mistake ran a script he wasn't supposed to run. But they dealt with it extremely gracefully. So first of all, they streamed live the engineers fixing the issue, which was amazing, such a level of transparency. And second, they never blamed that person. It was always about, okay, we need to fix the system.
Yeah.
This person shouldn't have been able to run this script. As easy as that. And then you need to.
So blameless culture is probably part of the green cards right there, right? If you don't have some form of it, you can't expect people to try and uncover flaws, even if it's flaws that aren't knowable upfront, right? But it's still going to probably.
And the issue is with the system, not with the people.
Yeah.
That's.
Yeah, I mean, by now I believe that's true for almost everything.
Yeah, for many things. All right, so we are past we are about 1 hour 15, which I think is a good length for this conversation. Yeah. It's as much as we could discuss about such a complex topic in quite a short time, but I'm happy with where we got. Would you like to say anything else in conclusion? I
think I've said it twice. I'm going to say it thrice. If you are building bridges that you've never built before, I'd love you folks to wear your helmets, because having that bridge collapse on your head is super painful, right? And I think everyone has been through this. So yeah. And for me, I really enjoyed the conversation, Alex. Happy you nudged me to having it. Sometimes easier to structure these kind of thoughts by just explaining it to each other. So thanks a lot for having the opportunity.
Yeah, I mean, I enjoy this a lot, because exploring topics, particularly when they are difficult, this is much better done in conversations, and that's why I did a little bit of nudging too.
That's totally fine.
All right,
awesome.
So thank you for accepting this and for joining me, and let me just do a quick outro. So what do you think about this? If you have anything to share, any other questions, we love comments, so please leave us a comment. We've also noticed that about 75% of you are not subscribed. It would help us if you subscribe. It's not mandatory. If you choose between subscriptions and the comment, leave us a comment. We enjoy those much more. And that's it. What do you think about this? Have you seen these issues? Are you facing some of these issues? Let us know, and maybe we'll be able to help with future videos, or who knows else. Thank you kindly for the view, and until next time, remember to think, design, and work smart.